Okay, good morning. So we've looked at 5.1 and 5.2. We've looked at the number e. We've looked at the natural logarithm, and we've looked at graphing exponential functions and their derivatives and how they compare to each other. And we've looked at graphing e to the exponent x and its inverse. So now we're going to look at derivatives of exponential functions. And basically, before I start here, the ln of x plays a role in the derivative of exponential functions. So obviously in this lesson, then we'll be looking at the ln of x once again, which is why we were looking at natural logarithms in the previous lessons. So just to recall here, the derivative of an exponential function is also exponential, right? That's the last lesson that we did. The derivative of exactly y equals e to the exponent x, just exactly that function, the derivative is the same thing, right? The exact same thing. So just to write that down, just to kind of remember this, the derivative of e to the x is e to the x. We are going to be looking at that and using that more today. So the derivative, let's just say, is the, in terms of graphing before, the derivative is the exact same graph, just literally on top of each other. Okay, and then here's something new for today. The derivative of, if I have an exponential growth or decay, so just a base of b, right? So the derivative of y equals b to the power of x. To get the derivative of that, I copy out the b to the power of x, but then I multiply it by ln b, and b has to be greater than 0. So ln of b is a constant. It's going to be just a number, right, that I can plug into my calculator. So this is when my base is not e. So this is showing me my base of e. This second one here is showing me when I don't have a base of e, when I have exponential growth or decay. So when the base is not e, so let's do an example. I'm just trying to see where to fit this stuff in here. I'm going to make my thickness a little smaller here. So if I have y equals, it could be any number, 5 to the power of x, 3 to the power of x. I think we used both of those in the last lesson. Then if I look, 5 is greater than 1, it's exponential growth. But 5 is also greater than my e value from the last lesson, 2.72. So this worked out to be the derivative. If you go back and look at the bullets there for growth, this would be a vertical stretch. I'm just going to short form that for room. Vertical stretch to write down. Okay, just a vertical stretch, right? It wasn't until we got into decay, which this is not decay, that we're talking about a reflection over the x-axis, right? So if it's a vertical stretch, then the constant, if I was getting the derivative, right? So here's the derivative we're talking about. If the derivative is a vertical stretch, then the constant, which is ln of b, right? B is 5. So in this case, we've got ln of 5. Ln of 5 is going to be greater than 1 in order to have a vertical stretch, right? And if I were to figure out what is the ln of 5 on my calculator, if you guys try that right now, I get 1.6. So just confirming that 1.6 is greater than 1. So just that makes sense that it would be a vertical stretch, right? Because to be a stretch, I need to be greater than 1. Okay. So the derivative rules apply to exponential functions as well. So great, all the same things we already know. So if g of x is a differentiable function and c is a constant, we're only looking at, well, I'm showing you 2 rules. We're actually only using 1 rule to this lesson, and then we'll do the other rules next lesson. So this constant rule is just saying, again, if my original function is just y equals a constant, like y equals a number, then the derivative is 0. We're actually not going to see that today, but that's should be familiar to you, right? That we've done in the past. So what we're looking at here is the constant multiple rule. And this constant multiple rule is, again, if I'm talking about an exponential function, right? So if I have y equals c, a constant, multiplied by a differentiable exponential function, then the derivative of that is to copy the constant down and do the derivative of the exponential function. Okay, so this part is, we did this last lesson. Okay, so now let's just practice that. So in these examples, just showing you, oh, I just noticed that C is messy there. I don't know if I can fix that on the spot in the video, we'll see, but hopefully you guys can adjust that. Sorry, I didn't notice that before because I guess my sheet was, that wasn't visible to me at the time, right? What was I saying? That as I'm looking at these examples, so be careful, because if I have a base of B, right, exponential growth or decay, I'm using this derivative rule. The derivative is copy down what's there, multiply it by the ln of B. If I have a base of E, then we're talking about like a constant multiple rule here, where this is an exponential function, right? Growth or decay, let's say. So let's move this up. So have these rules in front of you. Change my color here. I'm going to play with this for a second while you are, I don't think I can change this. Let's see. Oh, nice. Perfect. Perfect, perfect. And maybe move this guy over too, because I don't need that much room. Yeah, B is rather small, the answer. So, okay. All right. Get ready to go here. Get my pen handy. So differentiate, meaning get the derivative, right? So I have y equals 5 to the power of x, which is what we just looked at above. So this would be y equals b to the power of x. So in order to get the derivative, my base is not e. So I go back up to the top to, let's say, the second arrow on the page where it says the derivative, I'm just going to put it over here, right, is, just seeing the way it's written on the page, b to the power of x multiplied by ln of b. Do you see that second arrow there? So that's what we're going to follow to get the derivative of this. So the derivative y prime is equal to, copy down what's there, 5 to the exponent x, and multiply it by ln of the base. And in this case, my base is 5, so ln of 5. This is a constant, right? I can plug in ln of 5 or 5 ln on my calculator and get a number that spits out. So this is a constant. So just leave it there the way it is. I'm just going to show you this and then erase it. So don't go copying with me. If you were to write down, you know, usually if this is a constant, we put the constant in front, multiplied by 5 to the power of x, but people end up getting confused and multiplying these together. So I'm just going to say, for the sake of making sure there's less mistakes based on past, just leave it the way it is right here. Okay, so let's move on. I know I said this was not a base of E, but I did say this was exponential growth, right? Just before I move on, because I'm just looking ahead here to B, and I can see that this is also y equals B to the power of x. This is not an E base, so I'm following the same rule here. The only difference is that this is exponential decay, just to write that down. Exponential decay, just to review, because it is less than 1, right? It's 0.6666. So to get the derivative, let's just follow that rule. I copy down what's there, 2/3 to the exponent of x, and I multiply that by the ln of my base, and my base is 2/3. And then really that's it. I mean, you could figure this out as a constant number. You could get the ln of 2/3. And then if you had that as a number, I suppose you could put that number in front. But in terms of just getting the derivative, if that's as far as we're going, you can just stop there. So let's look at C is a little bit different than A and B, correct? Because C, you can see here, has a base of E. A base of E, and it's multiplied by a constant. So in this case, we're going to do the constant multiple rule. This is not the second arrow. There's no, the base is not B, right? So we're talking about a base of E, then we do the constant multiple rule. So the constant multiple rule, if you look at the very last arrow that's just above this here, it says that the derivative, just showing you here, is equal to copy down the constant and multiply by the derivative of the function. So our derivative here would be to copy down the constant, which is the 7, right? And then what is the derivative of my function? The derivative of e to the x, if you go way up to the top, we also reviewed that, is just e to the x. So it's the same thing. I can just write it as 7e to the power of x, the same way that it is here. I'm just showing here that I've actually completed it to get the derivative, but it ends up being the same thing. So just be careful with that there, whether it's a base of b or a base of e. Okay, let's do this example. Determine the equation of the tangent to y equals 3 to the power of x. So y equals 3 to the power of x is exponential growth. It's a b value. It's not a base of e. B is greater than 1, so it's exponential growth. And so we kind of know what that graph's going to look like, just kind of showing what it's asking us to do here, right? We've got our xy coordinate plane. We've got exponential growth, so, you know, roughly looking something like this. I'm not spending my time on that. That shouldn't be increasing, should be flat. And at a value of x equals 2. So at x equals 2, right, what would the equation of the tangent line be here? So we know it should be positive. The slope should be positive. So the equation of the tangent. So in order to get the equation of the tangent, I need my derivative, right? I need the first derivative. I'm just going to say derivative. I need my first derivative. So what I want to do is, here's my equation. If I want to write that out again, y equals 3 to the power of x, and get the derivative. So again, when it's base b, don't forget that we're using, just to point out this rule here, just to not write it out again, I'll just color code it there. So I write out what's there. So I write out 3 to the power of x, and I multiply that by the ln of my base, which is ln of 3. And then I want to evaluate. So I've gotten my derivative. I can't go any farther. Evaluate when x equals 2. So sub in, right, y primed at a value of 2 for x is 3 squared times ln 3, which is equal to 9 ln 3. Whether you want to put brackets around that or not, doesn't really matter. Now you can leave it like that, and that is the slope of the tangent, right? That's the slope. When you get the derivative, plug in the x value, you have the slope of the tangent. I went ahead and calculated 9 multiplied by ln of 3. I got a value of roughly 9.89, just in case you were testing that out. So in order to get just to change the color here, the equation of the tangent is not just the slope it's asking me for, it's asking for y equals mx plus b. So I have my m, I have my x, I have 2 unknowns still, y and b. So it's always that we try to calculate b, right? So to calculate b, I need to first get the value of y. So to get the value of y, to find y, sub my slope, sorry, not there yet. To find the value of y, I'm just going to sub my x equals 2 into the original, right? Because there's my equation with x and y. If I know what x is, sub it in, and I've got my y. So sub x equals 2 into original. So y equals 3 to the power of x equals 3 squared equals 9. So y equals 9 I have there, right? So then plug that into my equation, y equals mx plus b. I hope I can fit this all in here. I'm just changing colors so you know kind of when the thinking is changing. So here y is 9 equals slope of the tangent. I could put 9 ln 3, or I could put 9.89 times x, which I have. Plug in everything you know, and then you're left with your b value. So then 9 equals, if I multiply those together, I got 19.775 plus b, therefore b equals 9 minus 19.775, I got negative 10.775. So that's my b value. And if you were to leave this, just saying that this was, where are we here? 9 ln 3. If you were to leave this as 9 ln 3 times 2, then you'd have 18 ln 3. So you'd have 9 minus, or just saying you'd have 9 minus 18 ln 3 if you left it in ln, right? So therefore my equation is fill in m and b, leave y and x variables. Y equals m, slope of the tangent. I could have wrote down 9 ln 3. Let's do that. 9 ln 3 x plus b. B is negative in this case. If you want to write down negative 10.775, or you would write down so this mx plus my 9 minus 18 ln of 3. Or you could put that in as just negative 10.775. Just depends on, again, what your worksheet or back of the book is showing. So again, if you're looking at this, you look it up and it has values. Obviously, you can change that into values. If you have values and you look it up and it's like this, just kind of go backtracking and leave it in ln form. And it might also factor out here a 9. So you would have 9 bracket 1 minus 2 ln 3. So that could be the case as well. Just keep a lookout for that.